Alright, so I'm just going to look at the d9m file. And supposedly he's able to read the models in through Gnosis. There seems to be some issue with something. And then Dave is saying that he uh, says that there's not enough reverse engineering knowledge to completely read the models because of the way that they are formatted. So we're going to have to look at the format. So yeah, so these are all hard coded. Uh, Oof, why they hard code that? Oof, terrible idea. Should never hard code anything, especially all this stuff. That's pretty brutal. All right, so this probably won't do us any good, so we're just gonna have to reverse engineer it from the start. So I got both the files in here. We can see that there's some sort of count. And it looks like a bunch of faces. We know it's a bunch of faces because it's an index list where it goes 0, 1, 2, 3, 4, etc. So this is just probably the count for the index list. We're just going to take the smaller file and then we're going to see if that's true or not. So it probably starts here. I would assume it's not going to be 0, 0. That would make no sense. Oh, okay, I could be wrong. It is actually 0, 0, so it's actually very strange. 0, 0 is a degenerate face, so I don't know why that would be there. Okay, so I'm missing something. Okay, well, we're going to take this count. We'll take the smaller file. And we're going to skip down. 1, 2. Okay, so that's a little weird. Just a little bit. Okay, so this is the number of indexes that are in there, and it's probably a strip list. The fact that we hit a 1 there is actually kind of weird. And then we get another count. We could write all this stuff in right now. Just yeah, let's do just a boilerplate setup here. God. Okay. Sorry. All right. So let's just. This is the boilerplate code. Let's just basically just save this and then just spit it out again the next time you need it. Okay. Okay. Cool. Okay. Just review this. So we have this stuff is just some stuff to help us as we're testing. We want to be able to clear this thing. We don't really want any existing numbers here. This will help us, uh, see if we want to print a number or something to see what's going on in the file. We can see it, and we're not going to have it accumulate a bunch of numbers. And then, oh, sorry, this is what, yeah, clear listener will clear this thing. Sorry. This thing GC is garbage collection. If there's a file being held by 3ds Max, it's going to release the file, so it's going to unlock your files. If you lock a file, you won't be able to read or write to it. So you need to unlock a file. This happens when you open a file. It will automatically lock it, and you need to call the close function. So if you forget to close the file, then it'll get stuck open, like locked, and you won't be able to do anything with it. So we're just doing this every time we run it, just force close on the file, and then it will naturally just open the file. There's a few lines to opening the file, so you want to open the file. If it opened, then you want to do something. If it didn't open, we're just not going to do anything. And then here, once it opens, we're just going to pass it into this thing, this structure here, and we're going to read it, and then we're going to close the file. Okay. So the code flow is basically, the top here, we're going to create a rollout, and then if the rollout exists, we're going to destroy it, because if there's anything in here, we want to destroy it before we create a new one, because we're testing, right? So if I add something new in here, I want to destroy the old one. So that's why we're saying we want to destroy it. It's basically deleting this object before we create a new one, so it doesn't keep creating copies of itself. So anyway, so we destroy the old one, and we go in here, we define it again, and this is what we're defining. It just is a function to open the file, and then pass the file into the structure itself. And then down here, it will create the dialog if we wanted to have it. So I'm actually going to like comment that out. If you wanted to have like a dialog with a button, you could do it that way. So 3ds Max works a little bit different. You don't install components like a menu. You create these rollouts, which are little interfaces that go into the panels. Like in Blender, you have panels. It just docks itself as a panel. So we're just not going to do the panel. We're just going to use the rollout as a way of encapsulating all the code. So that way it's a little bit nicer. So there's a few types of encapsulation. The rollout is one of them. A function is another one, and a structure is another one. They're all a little bit different. They allow for just encapsulation, just putting stuff inside of stuff instead of stuff inside of stuff. And then down here, we're just calling the rollout and the function from the rollout, which is read, and then passing the file to it. So all this is boilerplate. This is the main function. So it comes down here, calls up a rollout, passes the file in there. In the rollout, it goes to the function read. It opens the file, checks to see if the file is open or not. If it is, then it passes it into the structure and then encloses it after the structure is done with it. And so that way, we're just focusing with the structure. Yeah. Okay. So all this is doing right now is in the structure we're defining a very topical view of what we're seeing in the file, and we're giving it comments. So this stuff in the green is a comment. So we're saying that its data type is a U unsigned integer, 32 bits, and then we're giving it a variable name, and we're initializing it to give it a default value. The brackets represent an array style of this type of integer, and the variable, of course, blah, blah, blah. So in the read function, we're then taking these variables within the space, inside the space of the structure, and then we're assigning it stuff. So the read long is a native function to Maxscript to read from a file, and the file is f. F is passed in through here. So f comes down, and it's using the unsigned option. Normally, when you use these functions, they read as signed, so they can have negative numbers. With unsigned, it means we're saying that the number is always going to be positive. It's not negative. Hence why it's called a uint. Usually, we could just say int, but I just usually go with uint until there's an apparent problem that pops up. Anywho's, well, I mean the bad problem is you go into infinite loop, I guess. So maybe it is safer to use ints. And I actually think about it. Who cares anyway? So here we initialize the array to make it blank again, and then we just check to see if the count is valid. So that means it's greater than 0. And then we try to dimension it, although I don't think you can actually dimension anything in Maxscript or Python, which to me is a little bit bewildering. But usually you would dimension something. So that is, if you're going to use a space, you tell the thing that you're going to be using this much amount of space. So if you're going to be storing 10 numbers, you say, hey, I'm going to store 10 numbers. But I think these languages are built to the point where you don't do that. But anyway, I'm trying to do that. So basically I take the face count and I give it 0. But that doesn't actually dimension it. I'm not really sure how if it actually does anything. But anyway, normally you would dimension something. And so we're trying to dimension it here. And then we go into a loop, and that's based on the count. So that's the count, and we're repeating a process per number of the count. And we're just reading in all those numbers. So we're going through, iterating through the array, and then storing in each value. And so that's it. So that's not too complicated. And that's code that we have so far. So it's not doing a whole lot, right? So let's go back into here. All right, so we have an integer. I'm not sure what this 1 is. It's a little bit concerning. It might be a integer type, or sorry, a primitive type, to say if this is a. Well, I'm not really sure what this is because there's a lot going on. But anyway, I don't know what this number does, so we might document it. I don't know. Okay, this is interesting. So we get this number here, and it gives us another number. It's a big number. That number doesn't make any sense. Hmm. Hmm. Okay, let's just check this one out. These numbers are exactly the same. that's messed up. Yeah, BCFA 11. Okay, there's something weird going on there. I don't know what's going on there. It's hard to say. We might just have to ignore that. But there's a number sequence there that seems to be the same, which is a little bit concerning. But yeah, whatever. All right, so then we get to let's look like a piece of string. So it says melta gun common. So we needed to see if that's a variable length or if it's a static length or a fixed length. So we just measure this probably to where the white space ends. And what am I reading there? The size is 36 characters. And we'll just go over here to where the white space ends. 36 characters. It's probably a good bet that it's a fixed size. Okay, so then we got to figure out what this list is, why this list is even here. There doesn't seem to be like a number. So this is 36, so we'll say that's 32. Okay, so we'll say 32 is the length. 36 is kind of a weird number. So we'll say that the string is blah blah blah. We'll also say that there is 1, 2, 3, 4. 1, 2, 3. No, it does have a number here. It could be just be 2 shorts and 1 long. That could be the material index. Alright, so we'll say 2 shorts, 1 long. And we'll put that in there. And then we're going to try and read the thing. Might want to store a function that we can reuse. So function read f string split with f. We're going to say position equals ftell. We need to supply it with the length. So then at the end, fseek position plus the length. Local string, oh yeah, string equals read string f. I guess it should look like this. Substring this 1, 2 length. Okay, so that should pretty much do it. We can print the name. So if I run this, it says I need to have a comma here. So it says, okay, so unexpected equal sign. There needs an equal sign on the function. says true, so that's not really quite right. So it goes into read. We can do a little print here just to see what's going on. Alright, so it gets to that point, gets to that point, gets to that point, then we're in this thing. Then we're at this point, got to that point, got to that point, but that's weird, it just doesn't have anything to say about f string. Okay, because I forgot to return the string. Okay, there you go. Melt again. Okay, everything is functioning there. Okay, so we're at 32. We'll just skip 32 here. That puts us here. Okay. I don't know what the fuck this shit is, but it's 64 bytes. I don't think I'm going to entertain what's going on here, but yeah, we just skip this basically, or we can put it somewhere. I guess we can put it somewhere. It's not a float value. Could be a half float. Yeah. In which case, it's just a series of shorts. So 4 shorts. 1, 2, 3, 4, 5, 6, 7, 8. Now I only have 8 of those. What could you do with 8 of those? Okay. Weird. I don't know what that is. I have no idea. That's freaking weird. Okay, anyway, save that and move on. Alright, so now we're down here, and that makes no sense. Bring this back out to 16 so we can get a better view of it. Okay, so interesting. Okay, so there's some stuff going on. Yeah, some definite stuff going on. This is the larger file. Alright, so we're going to focus on the larger file. It'll be easier to see patterns. So this is obviously a pattern. So this is, that's 18 times 2 is a 36. Yeah, so there's a pattern here. So that's, I'll just bring up the calculator. Times 36 I said it was. And then they have the name again. Okay. And then, okay, so this is, ooh, this is very interesting. Yeah. So where it says 0, okay, so this is actually like from here down. And it starts right at this thing again. So that means where this thing begins, it's a submesh. So we got to break this out. Yeah. The heck. All right, so just copy this out from here. This goes here. So I'm betting this is the submesh count. So we're going to just make that assumption. Submesh count meshes equals, blank that out. Oops. Okay. So, where are we at right now? Yeah, okay. So, basically reads this, and then we're decoding that, basically. Okay, so, yeah, so we could see this structure here, where we get the name, and then when we follow down the vertices, it, just down here, it repeats this structure. And this one had a count of 3, the other one had a count of 1. So I would assume that this being the second, this one would be the third, and it would just terminate to the end of the file. So this looks like it begins around this part. So this is probably the count. And we would probably do this times 36. And that would bring us to, ooh, actually I was wrong. There's a fourth chunk. Okay, we might not know the exact count. We can figure that out later. So, because the count is actually not quite known, it just exits after the first read until we can figure the count. We'll figure that out later. It's just important that we can get a submesh out, so we'll focus on the submesh. So, I'll just take it from the top again. So here we stopped reading at a certain part, so I'm going to go back to that point. So it was at the 16, and I think I might have screwed this up here. Excuse me. Okay, so this would have been reading through to, and then we're going to read this stuff here. Yeah, so that's where we're going to begin from, and then we get this count. Don't know what the count means. It looks like it flows into some float points. So this is a float point, and it just keeps going. So it looks like this is probably bound box or something, so it's probably not inherently important. Looks like we hit something that's a non-float, so we'll look for where the floats stop. So that's a float. That's a float. That's a float. That's a float. 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 I'm looking at this, by the way. Float. 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 It's possible that's a float. And then we get into the non-floats. So this seems to be floats. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 4. That's weird. I was thinking it could be a bound box. So this might be the rotation. So X, Y, Z, W. X, Y, Z, W. X, Y, Z, W. We could say that that's the floats for some component that we don't understand. And then this 100% is something to do with something else. And it looks like it flows back into not integers, but some sort of index list. Then probably this is the count for the vertices. So we're going to color that there. Okay. Okay, so this is where this FF thing stops. It says 5 again. That's not really helpful. It's just one instance. Same thing. Same thing. Alright, so it looks like we can't really get a solid answer out of this, which is unfortunate. This looks like it's the same across the whole thing. So this, whatever this data is, it's not changing. So yeah. Copy. And so I paste this here. Exactly the same. Okay, so this starts here. Yeah, it's exactly the same. So this data is kind of critical. 36 is obviously the stride, obviously. And then it just gives us a bunch of other important numbers, but we don't really know what they do, which is problematic to say the least. This says 5, this says 6, 1, 10. Oh, you know what? This is probably a probably a vertex table, actually, now that I look at it. Yeah, that's what that is, and that's why it's the same, because they're all using the same vertex type. Okay, well, that's not bad. That we can kind of work with. So with the vertex table, it would need to provide position, so you'll see a position progressively go. So this also should have a stride, and if it has 5, then it's gonna be 5 entries. So, oh, that might be it actually. 1, 2, 3, 4, 5. That might be it. Okay. It starts from here. No. Yeah, that's it. Okay. 1, 2, 3, 4, 5. Yeah. Yeah, that's it. Okay, so it's count, and then position. I don't know. Type, position, read type, and then channel. I bet you that's what that is. Yeah. Yeah. Okay. We can do that. So let me just move this over to the side so I can keep an eye on it, and we're gonna do that then. I'm gonna make another structure for that though. This is a vertex definition, and don't really quite know what it is, but yeah, so that's gotta be type. And then that's gotta be position, and that's data type. It's like data. Yeah, that's it. So it's just those 3. Yeah, function read f, and oh shit. So this, I don't know. Fucking figure it out later. Who fucking cares? All right, so we're gonna go with type equals read short f signed position data. So that's gonna be our vertex definition, and then down in here, I didn't really write that in there, did I? My bad. Okay, so after this is 32, and then so what did I got? 8 times 4 times 2, 64. Okay. Yeah, this is a series of floats. Alright, so that reads 64. And then it goes into a count. Once it goes into a count, goes into an array of these floats, which is confusing. 12 floats, so, huh. 1, 2, 3. Sorry, I just read myself. 2, 3. Maybe it's just easier if I bring it over here. And we'll set it for a size of 12, which it looks like it might be. Alright, so I think I read from here. So that's 1, 2, 3. Right? That's 1, 2, 3, 4. Is that feasible? So that's 1, that's 2. Wait, 1, 2, 3. So that would be 2, 3, 4. So it's 4 sets of 3. Okay. So just that is 48 bytes. And that is, I forgot what it was now. It's 3/4. Yeah. We'll use a vector type. Not that it matters. There's 4 of those. Yeah, I think. So there's 4 of those. 3. So that's 4. That's 3. And then just go read float. Thank you. Okay, so that should be up to there. And then I don't know what this stuff is. So it's 1, 2, 3, 4, 5, 6. We'll just say it's unknown. 6 of those. We don't have any clue what that does. Oops. 1, 2, 3, 4, 5, 6, 6, 6. Oops. Alright, don't know what that does. Not gonna worry about it. Then we get to the yeah, the vertex definition. So put this in here, I guess. So this guy. Okay. So just make sure that's mostly correct. So just okay. So read the count. Okay. We read 12 bytes of that because we don't know what that is. We read the count, and then we read each part of the table. So 1, 2, 3, 4, 5. It gives us the size or stride. Okay, and then we get the vertices. Oh, forgot the vertex count. It's also there. Let's call it vertex end. Okay, so we take the current position, we then add the vertex stride times the vertex count. That's the size of that data, and that should bring us to the end so that there's no problem when we're doing any operations. So, and then when we're doing the operations that we, this is already, I'm supposed to dimension this, I guess. So I take this and we can iterate through it. So for FEF in this, do this. For V in, okay, so that's not going to work. Wait, so that's going through each one of those? Yeah, okay. So local, I'll say V or vert. I'll say vec4. Okay, so we store a vec4, and then we're going through VFV. Okay, so we need to store the position. So I actually do need the position. So local f tell f, and then we can just put this here. So we take the position, local v position equals position plus, and so this is going to be dot type position. So that's position. Just double check here. Okay. So that's the type position. So that's, yeah, it's gotta be position. Okay. So where was I? Position. Okay, sorry. We actually do need to keep track of the. Yeah, sorry, I did screw this up. Okay, so for I equals 1 to the count do, and then we also have to store the vertex data. It's good enough, yeah. So, so now we're gonna go here. Um, Okay. So might as well encapsulate this stuff. If vertex count greater than 0, do so a clipboard there. So we're gonna blah 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 blah. So we're gonna go into a loop here. I think that's what I want. Okay, so uh, how about cod? I actually don't even need this to be honest, so we can get rid of that. Yes, position it's down here, and we just add the stride to it, which was up here. We dimension the vertex array. We then go and do a loop. We then we initialize each element of the array so that it has data in it, and that's what's stored up in here. We then go through each one of the thingies, and we store a default value. I think I don't even need to do this. I should just go like this. Fseek f. That would be my position plus the position from there. I'm pretty sure. Yeah, and then we're ready to do whatever we want to do with it. So we do case type of, and then we nest these. Yeah, and then we actually probably better just do a read. Yeah. So the types that I'm seeing are 0. This is probably position. 1. I have no idea what 1 is. We don't know what 1 is. There's also 5. I don't know what 5 is. It's probably blend weights, so it's probably normals? Blend weights? But the last 3, they gotta be UVs. It's gotta be. Oh, this is a bit different in that. Okay, so this is actually, I got this wrong. So this is actually 8-bit. That's 8-bit. That's channel. Sure. Hmm. Okay. So that means up in here, we need to store 2 channels. Okay, so the fuck am I? Okay. Okay, so the read type we still haven't quite figured out. We'll figure that out in a bit. but I'll write down what I'm seeing right now. So yeah, so do that. So the return value is, I guess we'll just make it 0. Or we could make it undefined, doesn't really matter. So case type of wait, it's probably a float. We're gonna leave it. I'm just gonna leave what the things are. So I have I have 22. Oh, I also have 6. Okay. So that's what it's gonna look like. And we're gonna plug that into the read function. Okay, so if it's a position, then we're satisfying. Actually, no, wait. This will go the other way around. Yeah. Okay. And then based on the type, we then do the assignment. Yeah. So in this case, it would be, yeah, vertex array I dot position equals our vect. That's vect for 1. Okay. And I don't know what the rest do. Nothing really matters. This is normals. Probably. These guys, it would have to be based on the channel. Oops. Okay. Get rid of that. I don't know why I did vec4 when all this stuff is. Oh, I did vec4 because of those blend weights. Okay, so I don't really know what that is. I don't think I'm gonna care about it. Okay. That looks a little more complicated than it should, but that should make sense. Okay. So I don't think I explained what a case was. A case or a switch is just basically same thing as an if statement. So in Python, they don't have a case switch, they just have ifs. So you would say if this is equal to 1, you do. If this is equal to 2, do this. If this is equal to 5, do this. If this is equal to 3, do this. So this is just kind of a bit of a shorthand. Instead of doing the if this, else this, else this, you just say the number and then the operation that you do with the number. So just it's switching. So if it's this number, do this. If it's this number, do this. So I find that it's a little more clean than if I'm doing a bunch of ifs. So I'm just going to leave it that way. So we just fill up vec4 and then we provide vec4 with a solution at the bottom. So that's what this thing's going to do, which means that I cannot return an undefined. It needs to define a default of vec4. And then we would proceed to fill out whatever the data type is. So now we have to go back here and we have to figure out what those data types are. So we know that the first one is type 6, and then the second one is A, and then we have 22. So now I need to figure out what those mean. So we're going to go into the 36 here. And I really should have wrote this down. So let's do that. Copy. All right, so what I got here? Let's clean this up a bit. Okay. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, 1, 2, 3. Okay. Okay. So this is our data type. Yeah, say that. That's probably good enough. There's actually channel, I think, here. So we're just gonna say channel. So type channel, we got position, and then data type. Clear enough. Okay. So this is the number that we're looking at, and we gotta figure out what those numbers do. So let's go for it. So we know that the stride is 36. Okay. That's the count. That's where the whole thing starts. And then we're here. And so that's a valid count. So that's 1, 2, 3. And then that stops. So we know that the type 6 is definitely, yeah. So we just take this. We're just going to fill it in. All right, and then we got to look at the structure of this thing. So we can see that this is starting from 0, and then it starts at 12, right? So we're going to see what the difference is between 14 and 12. So it's 8. Yep, 8. So if we go back here, that'd be this. Doesn't make a lot of sense, though. Am I reading that wrong? So it says it starts at 14. Yeah, that's fucking weird. Looks like it's 1, 2, 3, 4. It might be half floats. Might be. Which means I need a half float function here. No idea if that works or not. We're just gonna go with it because I seen someone say something about half floats. Yeah, that thingamajiggy. Now this is repeated twice, so it's probably normal and then tangent. So 1 and 5, 5 might be tangent. I don't know. And then 22. So we're gonna skip 8. And this is very peculiar. It's just two values. They're probably definitely the half floats. Yeah, okay, so copy that. This might not be half floats. It might just be signed shorts or something like that. I fucking don't know, but short f. I think I want to try it with integer first, and we'll see if it has. Half floats take more computation than if just using a short. So I think they would just use a short. So we'll just see what it does. I'll kind of leave it there. And so yeah, so that should. I mean, I might as well just fill this in. Fucking why not? So we'll just put in tangent. The tangent has 4 components though. 1, 2, 3. It does. It doesn't. 1, 2, 2, 3, 4. But the tangent one definitely has a 4th component. Definitely has a 4th component. I'm not gonna worry about it. Okay. Yeah. Okay. So I'll just do that. Texture coordinates. That only needs 2 components. My vec4, so this returns my vec4. This returns components. Seek back out. Okay, now let's finish off the file here. That's not right. Doesn't seem to be anything important there. Just needs a bunch of random shit. So I think I'm just gonna we're just gonna leave that. We're gonna bow out on that one, I think, and yeah. Okay. All right. So what I'm just interested in is at this point anyway, just to make sure that we can run the script and without crashing or anything like that. Let's see. Just fix some errors here. Expected. So the syntax is wrong. I'm not really sure what that's saying. There's no property Oops, maybe I did some spelling mistakes. Okay, so this doesn't exist anymore. I guess that should actually, yeah, so outside of the loop. Actually, it should be like right outside the loop here. So this would be, let me do it right here. Vertex end equals tell f plus vertex count applied by the stride. And so that's just going to seek to the end. So it says cannot convert undefined to type float. So undefined. So this goes to the vectors 1, 2, 3, 4. This would have been assigned to here through this type. This gets a default value. Something wrong here. So you can see that this read half float is returning nothing. It's kind of strange. So it takes, yeah, it goes out of here, passes this into here, reads it as a short, and then it does the math it needs to do on it, and it should return it. So specifically on the 3. So we got 1, 2, 3 is undefined. That is read float 1. F passes in. So something wrong with the F component. Undefined. That's weird. Okay, so we're gonna print some stuff. Okay, so we got the count, the stride. We dimension the array. I guess I'll put the array here and just blank it. We go to the count. We get the, that's where the position ends. That's actually wrong. Oh, okay, that was the only problem. Okay, so kind of get rid of that now. I'll leave it for now. And then I should have access to the mesh at that point. So yeah, so that should be stored within each mesh type. Okay, and then we should have access to all that data so that we can call a build function. Right? Okay. So for mesh or m in meshes do, then it would just be local mesh vertices faces. Excuse me. So meshes has a thing called vert array. So m dot vertex array do pen vert array with vert position. Then we just pass that in there, and then we can select the mesh. We're also going to delete all the objects. So after we read it, d9m dot build. So, okay, so I'm going to move this out of the way, and we'll just what the button is. Okay, it's gonna be like brought in a little bit. Save. Okay, everything's saved, and I should just build something. The fuck is that? Okay, wasn't expecting that. Scale. It's probably 2.54 or something like that. We should probably get the faces functioning, but I don't know if those are triangle lists or what the fuck. Actually, did I even read that one random number? I don't even fucking remember. I don't even fucking remember where the faces are. What the fuck? Okay, wait. Wait, are the faces just at the beginning? Wait, wait. How am I supposed to know where the materials are? What? Wait a minute. Oh shit, yeah, the faces are all at the... That makes no fucking sense. That makes no fucking sense. So that means that the, something in here must inherently inform us how this stuff works. That's funny. Yeah, okay. Okay. It's kind of important that we figure that out. So, yeah, okay, so under here, we want to print probably unknown 5 and unknown 7. So that's what we got. Ugh. That's kind of freaky. That doesn't look like jack shit. Okay. After, I think the number came right after the, oh yeah, there's these two as well, right after here. None of that stuff make any fucking sense. Okay. Yeah. There's the build function here. So let's read build. We're gonna take this and we're gonna just count So this is just a little trick to see if it is triangle list or if it's strips, and that's probably strips. So we're, yeah, probably strips. Just to double check here, Buddy posted a thing here. I don't know what I'm looking at. I don't use this thing. I think this thing is stupid. Where does it tell me what the index type is? God, it doesn't even tell me. It's fucking great. So it says step one, get face indices, and then he puts in the thing, and he puts in the count, but then where do you say what it is? So float. Just I don't fucking know. Okay. I think I seen someone say strip somewhere. Oh yeah, also the file here. Okay, so what he's got here. Okay, so loads up the model, hard codes a bunch of stuff, goes to the index buffer. He reads them. They're stored as indices. I don't understand what that means. What's he doing there? Is divisible by 3. Huh. Okay, so triangles. Triangle. Huh. He just reads it as a triangle list. Huh. It's not divisible by 3. Huh. That's confusing. Okay, unless there really was another number that was encoded in it. That didn't make a difference at all. What? I'm confused. Okay. Am I reading the wrong file? Okay, the count is being read as 563, which is what I get from here. And then when I divide this thing by 3, I get that. Excuse me. But I have a degenerate face. And then an extra face at the bottom. So it's almost like I skip 2 faces. But there's a shit ton of degenerate faces. That doesn't make any sense. That's a degenerate. And then I have another degenerate. They're not degenerates. Wait, they're like quads. It's so fucking weird. They're like fucking degenerate. Okay, so obviously this must be a triangle. Because if you did 3, 3, it would be a degenerate. So this must be a triangle. And then why it starts off with 0, 0 makes no sense. It's almost like it's doing 4, but that doesn't make any sense because then if I go 1, 2, 3, then I have degenerates. That's got to be a triangle list. Or triangle strip. I have strip algorithm here. Uh, it's funny. I don't really use triangle strips in my programs anymore because they don't really use them anymore. Um, bullet which might. Can't remember the last thing I would have used strips on. Oh, there we go. There we go. Grab that, and I shall adapt that to this thing. So, okay, we got, just put it in here, I guess. Okay. I'm just gonna give it the array. That's not necessary because it has access to the array. All right. Okay, so it goes through the array, which is kind of stupid, but anyway, so it goes through the array, checks to see the reset, and then it da-da-da-da. It looks like I would be applying the material array or whatever, and I'm doing a read. In this case, I'm not doing a read. I'm reading from x. So x would have been 0, x is now 1, and then x has now become +2, so it needs to move down here. So then we have the array, which we'll put here. So that's vertex array x +1 +2, I think. And then we go and we increment the array. Okay. And it looks like I'm appending this thing. So actually we need to supply it with face array, which is this thing. So we append the face array with ABC blah blah blah, and then I don't know. This is we swap around the components. I would imagine this would just be whatever x is. Since this is a part of this, x increments by 1. Yep. And then we check to see if this is this. Or is greater than -1? Yeah, I don't know. Okay, and then I guess and this is this. Okay. So we take the vertex start. So this face add. Where's face add at? It just keeps adding it to it. Vertex start 0. So just default those out. We're flipping the faces around. And I found a better way of doing this later on. It's interesting. You just use a bit operation, but we'll just leave it with the true and false. We got it's appended, that gets appended. Not really sure what the reset is doing. Okay, and then I should kick back out. Okay. That's triangle strip. And now we can go face array gets plugged into there. That's it. And then it doesn't return anything, just modifies the array. Okay. And then we'll see if anything happens. Crashes. Nice. Says cannot get function for undefined. So it's saying that the array is undefined. So if this is less or no. Oh, for God's sakes. Okay. Oh, that was stupid. Okay. Yeah, get over there. Okay, so it was that. Okay, it's just a gun. It's fucking big. Okay. Alright, well that's that. Okay, and then if you want to get the UVs in there, there's a little bit more code that we need to do. Let's see. Okay, I kind of take back what I was saying earlier about like when you're making a NOSO script, it would be longer because it's actually pretty compact. This is only 137 lines of code. Mine's like double that. It's 300 lines of code. It's because of all the compound functions. Like you're doing this, like you stream in a set of commands into the function. There's no structures. It's just a lot of it's just hard coded. So it's still I don't know. I'm still iffy on this on that. And then when you're using, I forget what RAPI stands for. Something like Rick is amazing or something like that. Yeah, you just stick them in. Again, they're all compounded in there. I'm not really seeing any particular information about the format, so I'm gonna close that. Mine, I try to do as linear as possible so you can see where things are grouped into each other. I'm trying to define the type as simple as I can. The code is still kind of complicated, I guess, in that regard. You can be overwhelmed and then still just as much be confused. Then, the code's really compact. I don't know why I'm just talking to myself, muddling myself. That doesn't have anything to do with anything. We're just going to test the other file, so let's go do that. So, grab this one. Perfect, it crashed. It's good. That's always a good sign. So it says vertex array. It says unknown property vertex array. In undefined. So saying that M is undefined. That's interesting. Alright, so saying I have 3 meshes and I only read 2. Oops. So to get out of this, we're going to exit. Alright. Ooh, interesting. Oh, isn't that ugly? So there must be triangle strips and triangle faces. Yeah. Or a triangle list. We'll just go in here. We'll just monkey this. Yeah, okay, so it'll just be face array dot count divided by 3 as integer. 1, 2, fc do append face array I local face for v equals 1, 2, 3 do face equals x is 1. Okay, so we're gonna change this around a bit. So this is gonna be face array, which is gonna be x plus equals 1. Yep, and then we just append with face. And we have all this magical stuff that we can do. Add that and subtract vertex start. I think that's what all that stuff was. Alright, so something's triggering it to be one or the other, so we'll have to keep an eye on that. Yeah, so something is triggering it to be one or the other. So we're going to copy this. Okay. 25. Okay. 3. For meshes, one says 3. Alright, I don't see any difference. So my hunch is that it's this 3 is actually the number there. So, yeah. So just shrink this down. So we want to count. Yeah, count occurrences. The 3 occurrences. Okay, so yeah. So that is the count. Oh, here we go. It's unknown 5. Okay. Oops. Face type. Cool. Face type is what? Okay, so that does mean that somewhere the faces are uh they're whatever doobly dude. So it means we'll have to figure that out in a second. So we'll first go back up to read and take out this. And we want to make sure that we're printing stuff from in here. And we're going to want to do the larger one, which has the three submeshes. Yeah, so it's oscillating between the types. That's problematic. Okay. It must just go from the last. Nothing here tells me the position in the face array, which is just infuriating. Okay, so there was some stuff that I didn't print. Oh, look, I forgot to, this is 6. It probably doesn't mean anything. Um, okay. It could just mean. Oh, it doesn't make any sense. It didn't tell me. Uh, how many faces to read in each subsection. plus account. And we just read them raw. And then I don't know. Okay, so after I read the face data, oh, it's just not here. It's down here. We read unknown. There's two of them. Unknown 1, 2. Unknown 1, 2. It just says 1. That gives me like a random number. That gives me this count. Fuck. Huh. I don't understand. The face read type, if it is the face read type, is changing. And let's say it didn't change. That doesn't fucking matter. Because how do I know where to read the next face? That is fucking crazy. So I would need a face count next to where the face type is. That, or we assume the face type is all the same. Okay, so I go back to the bottom here. This is going to give me all the faces. It should crash, but it doesn't. I'm very confused. 8,001 faces. Oh, here we go. That would make sense. That would make absolute sense. Okay, so I have so many fucking vertices. That's a lot of fucking vertices. Okay, so I build the first one, and yeah, so yeah, it's 9,000 whatever fucking feet. Hmm. How the fuck do I get rid of those? It's not exactly the simplest shape to... Yeah, they're fucking everywhere. Yeah, I can see them across the wheel. Oh yeah, they're all up in there. Yep, that's also bad. Probably that as well. That. So those are the faces that are the ones that I clicked on. It shows around 7.5.12. So this is the bigger file. These were triangle strips. I read them as triangle strips. So that means to get to that face, it's 3 times 2. So where I'm finding the invalid, one of the invalid faces would be that amount. Well, there you go. So that's very clear that that's where the reset is. So we can just search for the reset position. Yeah, that's where the reset position is. So that's like, okay, so we confirm that. That's definitely where the second mesh comes from. So we can also do some math on that. Figure that out precisely. So that that's the size. Do some math on that. So that's the raw size divided by 2 divided by 3 would give us the face count. So the face count is 7508. Let's do all search. Interesting. Okay. Interesting. Very interesting. Where the how the fuck did we get that? I do not know. Like, okay, what if we just divide this by 2? Divided by 2. Oh, shit. Okay. That's interesting. That's really interesting. What? Oh, it popped up. Oh, it popped up in that weird ass array thingy. I printed it though. Oh yeah, I printed it right here. I didn't really notice it. Okay, so that was fucking. Which one? Yeah, yeah, this is it. Yeah, okay, cool. So I don't know why it's like that, but it's repeated several times over. No problemo. So this must be. Yeah. Okay, so this must be the position. That must be the amount of faces. Yeah. Okay, and so let's just double check how I'm reading that. So we're printing 04. So those probably aren't shorts. So it's this guy. It's yeah, it's probably just 2 values. Yeah, and we just get those. Yeah. Hmm. So it's got to be position and whatever. So I guess we'll name this properly just to get it to. Let's call this buffer. Beef info. And it's going to be int 32. This is going to be position. And this is what I call it, face position or face start. And this is number of faces. Okay, where the heck am I? So face info, 4 bytes, and this seems to be fixed. It's 8. Don't know why. Don't care. So over here, we're reading this 8. It's just gonna be face info. I equals this. There we go. We just get rid of this altogether. And then now I should be able to build the submesh. Submeshes are reset to 0, so we have to carry the number of vertices that are in each element. Yeah. Okay, so so fucking confusing. Hold on for a second. Okay, so vertices. Okay. Okay, fuck confused. Alright, so this is gonna go up here. We have the vertex array, we have the face array, and then we go into the vertices right away and we collect the vertices. No, are the vertices a part of each mesh? Yes. So that's hella confusing. Alright, so this is each mesh. Like this is gonna create a submesh, right? So we're gonna take that out. Each one of these is a different material, so each time we call this thing, it needs to have a material ID. And I guess also needs to have a material array. So okay, so yeah, I think everything just stays the same except these are on the outer side, and then we just complete the mesh inside this bracket. Material these would then just be that. Okay, so we're going through each mesh and we're grabbing their vertices, and then we're appending them. And then based on there's going to be a type. So what would be under m dot face type, and 0 is, I forget which one is what, but 1 and 0. So I think 1 is triangle list. So that's triangle strip. And that's triangle list. Okay. And then we gotta pipe in, get over here. And then there's all the other stuff. And then there's the face add. First face start. Okay, so in triangle list, we or triangle strip, vertex start subtracts. So when it's okay, so when we go to the second element, it's resetting. So we're not doing it that way. So we're taking the face add. So I think, or I had offset. We'll put 1, and then that's just whatever the fuck I called it. Face offset. Okay. So that's how that's gonna go down. And then each time we go through a loop, we need to take fuck. So we need to accumulate face offset. So face offset is accumulated by okay, so hold on. I think it would be the largest face. No. No, it's just the vertex count. So this thing. Yeah, so it's just face offset plus equals this guy. I'm pretty sure. I think. Probably. Most likely. So that means that fucking I don't know. So this is getting access to. Okay, so this needs to change a little bit. So. Okay, so I need to supply it with. Yeah, so face start and face count. Face count is in here already, so I gotta do start and count. Start and count. Okay. So face information is inside the mesh itself. Yeah. Okay. So in meshes, and then I'm gonna have m dot face info. don't know why it's duplicated 100 times. We'll just take the first element. And then we have access to, I forgot what I called it. I think I just check add stuff. So I have access to start face and number of faces. Okay, so that's gonna pipe into start and count. This is already getting kind of lengthy here. Okay, so it means that both these functions now have access to the same shit. Just okay. This thing should be like 1. And we'll just yeah. Okay. Okay, so now this has to change a little bit. So face start. So X is being used to read through the array. Okay, so X needs to be start, and then the count needs to go here. And then same thing here. So we take the count, and then this would just be, I already fucked it up now I think about it. Okay, so we got start, it's the start face, which, oh shit, that could also be 0. Because start is an address. Oh fuck, hold up. Start will be 0. I guess I just add 1 to it, I guess. Start would be 1. Okay. So 1, 2, that would be the count divided by 3. I don't think that's quite right. So that's number of faces. But let's say the start is like way the fuck out of there. Like this one. So I start, and that's the count. That's still correct. It's just, yeah, so that's 1. And then I access the array, starts at 1. So it's 1 plus start. Or rather, start plus whatever. Okay, I think I got that. Through some mental coaching, that seems to be the correct way of doing it. In that case, that would still be 0. So that's the count. X less than count. The only difference is I just take start plus X. Yes. I think that's right. Yada yada yada. So that I don't even need to do this. That was annoying. Okay. Okay, what's it saying here? Uh, the types are incompatible. Oh, yeah. Okay. I'm still getting webbing. You just can't see it, which is weird. It's fucking weird. Okay. Huh. It's got a fuck ton of degenerate faces on it. I'm confused. And then 3. Oops, I didn't mean to do that. 3. Oh, I fucked it up already. um. Getting kind of confused here. Yeah, might be fine. Like, it's just a lot of degenerate faces for whatever reason, but I don't see anything particularly trash about it, so I guess it's kind of okay. Let me just copy. What do I have here for this stuff? This is for the UVs, I believe, so I'll just copy. This is for multi stuff. Not worry about that. Okay, so tverts. Okay, hold up. I'll deal with that in a second. What do I have here? So it builds faces. Sets the faces. Sets a random wire color. The name. Where's the name come from? Name comes from the submesh. Okay. Okay, so we'll set smooth groups. Okay. So T-verts, we need to transfer the T-verts. So T-verts. Do that, blah, 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 blah. Oops. Does not get multiplied. Oops. What's going on there? Okay, so that's T-vert. Whatever, so that goes into there. And that should do it. Alright, so I get a crash on here. Okay, I'll just check up on the UVs. That looks like it's like a fucking shit show. I don't know what's going on there. Okay, that looks correct. That looks like shit. That looks correct. I don't know why the second one's corrupt, but that might be fine. Not really sure. Base for again. Okay. It's supposed to be random. Change those two. They max out at 100. Yeah. Okay. Not really sure what else I was gonna do. I was gonna do something. I totally forgot what I was gonna do there. Hmm. Yeah, whatever. Let's import that. And yeah. Okay, I don't think there's anything else I can do there. UVs probably work. I don't have a texture though. Can't really test it that way. This looks corrupt. Oh yeah, but that looks super fucked up. I I don't get it. Are those just degenerate face? I'm so confused. It, it's probably something wrong with my face strip algorithm. Wait a minute. It's definitely something wrong with this thing. Because I know you're supposed to, if you get a degenerate, wait, You don't skip if you don't have a degenerate, though. You just skip it. Where you skip it, why you skip it, I can't really remember. But there's a fuck ton of degenerates in there. And that's what those little lines are. They're degenerates, but you don't see them because they're just a line. I think they get deleted when you convert to a poly. Yeah, but even still, I mean, uh, I'd have to look up some older scripts from a while ago. Yeah, see the degenerates are gone. To figure out what the actual algorithm for that is. It doesn't really matter because if you're using Gnosis or something, you just filter its way out anyway because it has its own algorithm for decoding the strips. Okay, so just I think that's it. There's nothing else to do. Now we could try to get ChatGPT to actually produce a working program for this. Your results are going to vary. So if you have a really simple format, it's going to be no problem. Because you can say, hey, for example, let's just take this first part. Right? It's simple to convey. It's easy for it to write a program for, right? So you can say, I have a file. It has a count that's a 32-bit integer. You read that, and then you have an array of 16-bit integers from the count. And so it'll understand what you're saying and make a program that reads the first 32-bit integer, the long value, and then reads all these small values. So that stuff it can understand. So using ChatGPT as a tool, kind of like pre-calculator era where everyone was just using pen and paper, and then now you have a calculator, right? Like I have a calculator, but I don't use it unless I need to do math. So ChatGPT, you're not going to use it unless you need to use it, but you're going to use it within its limited capacity, what you know what it can do for you, right? So you're not going to take a calculator and be like, make me a skateboard, because it doesn't know how to make a skateboard. But it has formulas in it that will allow you to make, using your knowledge of trigonometry and stuff like that, to help you get those calculations using the calculator. So ChatGPT is kind of a glorified calculator in that sense. It has a wealth of information, and given the proper prompt, you can get it to get you or give you a chunk of working code far enough that then you can just tailor stuff to it. So I'm not going to bother to do that now. Literally, the code is done the way it is, and we have a good understanding about how everything works. So, yeah. All right, that's it. Sorry the video took so long, but it's a real-time walkthrough of the format and programming of the format. Okay, bye.